Alright, for this video I want you to have a few things ready. I want you to have a piece of lined paper. I want you to have some kind of straight edge. It can be a ruler or even an ID card or a grocery store club card or whatever it is. And I want you to have two different writing utensils. I'm going to use a blue pen and a red pen, but you could use a pencil and a pen or different colored pencils, anything like that. Alright, in today's video, so if you don't have those things, to be clear, go find those now, pause the video, and then come back. In today's video, we're going to really be focusing on looking at how to make our math work look good. So the first thing that I want you to do is always, from now on, if you're doing math on a sheet of lined paper, I want you to take that piece of paper and I want you to fold it in half like a hot dog. So let me zoom in so you can see it right. So we take it the long way, take the paper, and we fold it. And you can either leave it folded or you can unfold it just so you can see the line. All right, so you can see that line down. But we're going to treat this paper now as two separate columns. And the reason we're going to do this is because math just works better when we work vertically, when we work down the page and try to avoid working side to side. So what we're going to do today is we're going to create a gallery of inverse operations. And inverse operations are effectively things that undo operations. That's a horrible thing to say and a horrible way to define that, but it's what I'm going to say for now. The focus of our work today, though, is not going to be about what the solution to the equations that we're going to be solving are. It's going to be about how we write it down. So I want you to focus on exactly what symbols we're putting where and how we're organizing things. If you have handwriting that is naturally awful, like mine is, you're going to write slowly so that it's legible, neat, and organized. So, number one, we're going to be asked to solve negative 3x is equal to 12. So let's just break this down real quick what they're asking us to do. They want us to solve, meaning they want us to find the value for x that makes this equation true. Most of us can look at this right away and say, okay, well this says negative 3 times x is equal to 12, so it's going to be negative 3 times negative 4, so negative 4 must be the solution. Great, grand. We're not impressed that you can do that in your head. What we want to be focused on in today's notes is how we can do that on paper and write that down and communicate that clearly. So if we have negative 3 times x, if we're trying to write this solution clearly, what we want to do is we want to create an equation that's equivalent to this one that has the same solutions but just has x by itself or just has one x. So the question is, what do we do to negative 3x so that negative 3x could become just x? Well, it's negative 3 times x. If we create a division in here by negative 3, then this new thing that I have would be negative 3x divided by negative 3 would just be x. In order for the new equation that I have to be equivalent, I have to divide both sides by negative 3. 12 divided by negative 3 is negative 4. So this new equation is equivalent to the original one, meaning they have the same solutions. It's clear that the solution to this is negative 4, which means the solution to negative 3x is equal to 12. Must also be negative 4. All right, so we're going to create a little gallery here. So do me a favor now, at the end of this problem, go ahead and draw a line across the page. So some good style points here, right? We're working down, we're keeping our equal symbols relatively lined up, and we're boxing our final answers. In this case, our answer is a solution because we're being asked to solve. Number 2, we're going to be asked to solve 7 is equal to x over 3. Okay, so now we've got x divided by 3. If we were to take this and multiply both sides by 3, we could have 3 divided by 3 is equal to 1, in the same way that here we had negative 3 divided by negative 3 equals 1. So the way that we multiply both sides by 3 is to wrap both sides in parentheses. We wrap the 7 in parentheses, we wrap the x over 3 in parentheses, and we're going to multiply on both sides by 3. So when I do this over here, what's going to happen, you could write this as, 3 over 1, so x times 3 over 3 times 1 gives you 3x over 3, blah, 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 right? Or just say, okay, I've got a 3 on top, a 3 on the bottom. Those 3's will divide out to 1. And so all I have here is just x. On the other side, I have 21. And if 21 is equal to x, then x is equal to 21. And we're going to box our answer there and sketch a line across this so that we can clearly see that that's the end of that problem. We're going to write number 3 for our next question and move to the next problem we're going to do. The next one we're going to have is x plus 3 is equal to 11. Right? Again, we're trying to get to 1x. We already have 1x here, but now on the same side of the equation we have a 3 being added to that. So to have that 3 become a 0 in this case, right? Here we wanted this negative 3 to become 1 so we could have 1x. If it's being added, we want that to go to 0. So we can subtract that because 3 minus 3 is 0. So we're subtracting 3 from both sides. Again, we write the subtraction, we write the line across the bottom, and then we go ahead and do the subtraction. X plus 3 minus 3 is just x. 11 minus 3 is 8. So our solution is x is equal to 8. And again, we sketch a line across, and we've got number 4. All right. On number 4 that we're going to do, we've got 11 is equal to x minus 3. Right. So here we have a negative 3 that we want to have be 0 effectively. So we're going to add 3 because negative 3 plus 3 is 0. So we add 3 to both sides. 11 plus 3 is 14 is equal to x. Or another way to say that would be to say that x is equal to 14. I'm pretty close to the bottom of my page now, so I'm going to go ahead and flip to my next column, just flipping it over. Right? So we can see if we open this up, I'm going to be working over here now. Right? And it's just going to be for one last problem. We've got 1/3 x is equal to 6. What did I not do? I didn't write down what the problem said or what number we're on. So we're just going to neatly cross that out. If you're working in pencil, you would just erase that. This is problem number 5. On number 5, we're going to say solve 1/3 x is equal to 6. So just like when we had negative 3x is equal to 12, we want this 1/3 x to just become 1. So the question is, what can we do to 1/3 x so that we just have 1? You could say that you're going to divide both sides by 1/3 in the same way that we divided both sides by negative 3 here, but that might be a little bit confusing for some of us. So let's think about this a little bit harder, right? If we said we wanted to divide both sides by 1/3, dividing by 1/3 is the same thing as multiplying by what? By the reciprocal of 1/3, right? Which is 3. So what I'm going to do to get this 1/3 x to become just 1x is I'm going to multiply, so I wrap in parentheses, both sides by 3. The reason I'm doing it on both sides is so that my new equation is equivalent to my original one. 3 times 1/3 is just 1, so this is just 1x, or x is equal to 18. Right. Here's the big important piece about tonight's notes. If your page doesn't look exactly like this, without maybe the crossing out stuff up there, then I'm not happy with what you're writing down. This is exactly how we should be organizing our work. And as you work through the problems in Con tonight, I want you to make sure that your organization looks exactly like this.